Hi.
Hi, Emily. How are you?
I'm good. How are you?
I'm good. I apologize for Wednesday night. I just
Oh, no.
completely ran out of steam. When we
You're
got to
fine.
that last question, I was just brain dead. So,
I
um,
figured it out with some classmates, so it was good.
oh, I tell you, that was a long day. I had originally blocked out that hour because I had so many sessions that day.
Oh, I'm so sorry.
Well, that's all right. I'll always do calculus. I want to learn it better. But anyway, if you need me to go over that problem, I'm certainly willing to look at it, and we can do it on Sunday or whenever.
I think I got it. So
Okay, good, good.
all we really had to do was,
Figure out the sixth term?
no, we had to figure out the seventh term.
The seventh term, okay, yeah.
And the
That's
sixth
the way,
term had to be,
yeah, that's kind of one of the essence of the remainder problems, is the remainder is always less than the next derivative would be.
yeah.
And so, all right. So are we back on SAT?
Yes, please. And then next week, I think we'll start, on Fridays at least, start doing AP review.
Okay, AP Calc review. Okay, good.
Yeah.
It'll be fun. I've been doing some of that with other students. So it is. I enjoy it. I love it. Those are challenging but doable. None of the ones on the, well, I don't know about the AP Calc BC. I've been doing the AP Calc AB. And that's, I don't come across very many problems that I struggle to figure out how to do. But
Yeah.
the Calc BC could be a little different. I guess we'll find out. But anyway, let's see. Last time on the SAT, we got through problem 5. So let's start with this problem, which is 6.
Okay.
Figure not drawn to scale. Okay, I'm not sure if that's meaningful or not here. I guess the number one question you have to ask yourself is, can you solve for r minus s as an entity, or do you have to solve for r and solve for s and figure out what r minus s is?
Well, S is equal to 55 and R is equal to 125.
You just answered the question. Or 70, excuse me. 125 minus 55?
Mm-hmm.
Yeah, 70e. Yeah, it's simple enough to solve for r and to solve for s. Some problems are going to be, however, like this, and you cannot solve for r or s, but you can solve for the r minus s. You know what I'm saying?
How so?
Well, this is not perhaps a good example, but can you solve for r minus 3? Hold it. Hold it. Hold on.
Yes.
Yeah, that's not a good example. I was trying to think of one. In other words, I can solve for r minus 3. That has to be equal to 5, so I can solve for r. I don't know, I can't think of one right off the top of my head where we'd be able to solve for this difference, but we would not be able to solve for either R or S. It would have to be kind of a unique algebra problem. I'm sure we'll get to some.
$15.
What's 2 weeks prior to the 15th?
The first?
So that would make it the third Friday.
Okay, so it has to be 14.
Yeah.
Three to 4?
Hold on. So, once again, I haven't even read the problem.
Wait, no, I don't think that's right. That's not right. Never mind.
So, what's the first thing we can say?
That 3e equals 4s.
They want the ratio of S to E.
So it'd be 3 to 4.
Uh-huh.
Or
In
4
other
to
words, you
3.
merely have to manipulate that equation to get S over E. Divide both sides by E, divide both sides by 4. S to E is 3 to 4.
So I was right.
Uh-huh. Let's see, hold on. 664. Tell you what, we don't have many more high degree of difficulties here. I'm gonna have to go and search. So you don't take this test till the fall.
No, I take it in June.
Oh, that's right. That's right. Yeah. Hold on. What's the percent decrease from 88 to 86? Or from 86 to 88, excuse me. What is the percent decrease?
It goes down 20%.
What?
20%.
20%, yeah. Yep. Okay, so it's down 20%. So if it's 4 and 88, what is it going to be in 1990 if it continues going down 20%?
3.2.
Yep, B. Why in the world do I have a dot next to C? I don't know. Hillary. They were ahead of their time.
So it'd be...
This is a perfect question for what method? And I do mean perfect. This is almost the quintessential question for back solving.
It's 80.
Okay. What'd you do? How'd you do it?
So if the first 3 installments are twice as many as the remaining 9, I just did 6 plus 9, so 15. Divide 600 by 15, you get 40. Multiply that by 2, you get 80.
Okay. That was the algebraic way to do it. The reason I said, and that's fine, if you can do it algebraic way, more power to you. Not everybody can, so back solving is a good fallback. But the reason I said this was the quintessential question is because this is, if you start, in other words, let's say you couldn't formalize that as an equation. And you're going to pick one and see if it works. Well, this is where you want to pick either B, the second lowest, or D, the second highest. Because you're going to know whether you go up or down on the next, when you test that. Let's say we tested 35. Well, 3 of those is 105. And the rest would be 9 times 17. That does not add to 600. We know we need a bigger number. Right?
Okay.
In other words, this is the kind of question where when you test one number, you know whether you need bigger or smaller. And that's the perfect question for back solving because it guarantees you're only going to have to do 2. So 35 told me I need bigger. So the next one I'm going to try is 65. Well, 65 tells me I got 3 times 65 plus 9 times 30, 250. That also comes up less than 600, so I need bigger still, so I have my answer. In other words, you never ever have to test more than 2 to get the answer. If I tested D and it said I needed less, I would know that the answer was C. If it said I needed more, I know it's E. If D is correct, I'm done. So this is kind of like what I call the marble problem or the age problem. Those are other problems that are perfect for back solving because you always know which way to go if the first one you pick does not work. Looks to me like this goes from -2 that way and from +2 that way.
D.
Good. Not all of these are high degree of difficulty. Now, they're all either high or medium. But in order to pick the high degree of difficulties, I had to photograph the page that had the mediums on them also.
Yeah.
And I didn't circle the ones that were just high only. So, but that's okay. It's good to review the medium and the hard for you.
D.
Which one?
D.
D as in David?
Dog. Or
Dog.
David.
These seem like such a piece of cake for you.
And yet I don't do very well on the test.
Well, that's what puzzles me. I'm absolutely flabbergasted. I don't think I've ever worked with anybody that got these quicker than you do.
AB equal to 8. So if AB is 8, oh god, I hate these.
Well, don't.
It's that weird rule.
No, just remember your 2-unit triangles. You have a 30-60 unit triangle. You have a 45-45 unit triangle. Both of these triangles in this picture are similar to these two triangles. What are the dimensions of my unit 30-60? What's opposite the 30?
A to D.
I call it my unit because it's always 1 opposite the shortest angle, which makes this one root 3 and makes this one 2. And in the 45-45, it's 1 square root of 2. So both of these triangles are similar to these two triangles. So let's look at this one.
So that one's going to be 8 root 3.
Well, not 8 root 3.
4 root 3.
4 root 3. So the similarity ratio is 4. So opposite the 60 is going to be 4 root 3. What's this side over here?
That's 2. 4.
And then this triangle here. Now that we know that's 4 root 3, what is this side right there?
4 root 3.
Okay. So now what is the area of triangle BCD?
So it's going to be 2.366.
I don't think we need to even get into decimals. The base is what?
I didn't do that right. Never mind.
Remember where it's this triangle right here, not the whole triangle.
Yeah. The base is 4 plus 4 root 3.
4 root 3 is the base, not 4 plus 4. BCD is this triangle only.
We're looking for that triangle.
Yeah.
Gotcha.
Okay, so this is the height, this is the same thing. And when we multiply all of those together, we get 16 times 3 times 1/2, or 8 times 3, 24.
Gotcha.
That's a pretty good problem. But not difficult at all if you know those two basic triangles.
Yeah.
This looks interesting. You don't see a problem that looks like this very often. Wow. Not hard.
15.
Yeah. We'll come across one yet that we'll be able to solve for that difference, and we won't be able to solve for S or R.
I like that problem.
Yeah. Well, you like geometry.
Yeah, I do.
Okay. This is definitely one of the harder ones, if I remember right.
Yeah, it looks harder.
let's see, what are they asking for? If the rectangle has a perimeter of 12, what is the area of the big triangle? X, Y, U. Yes. Wow.
So we're going to be working with integers. So the sides of the rectangle can
Let's
be
call these A and B.
So the sides of the rectangle can either be 1 and 5 or 3 and 3.
Why does it have to be integers?
Because the answers are in integers.
But the answers are for the area of the triangle.
But it's always cleaner if all of the answers are integers.
Gosh, I'm trying to remember how I did this the last 3 years ago when I first looked at it. Well, when you don't know where to start on a problem.
Let's start with a little triangle.
What's that?
Let's start with a little triangle.
There you go. And it's going to be similar to the big triangle.
Mm-hmm.
But what I was going to say is when you don't know where to start writing what you know. The only thing we know on this, well, we know that side is the same as that side because it's an isosceles right triangle.
We know we have 3 similar triangles.
Yes. And you also know that 2A plus 2B equals 12, which means A plus B equals 6. Wow, this is a brutal problem. I kind of see what we have to do. If this is, wow. What I'm thinking is that this measurement from here to here is Z minus B. If this whole thing is Z, then this little triangle would be Z minus B. And then if this whole thing has to also be equal to Z, so this would be Z minus A. That's just from there to there. Wow. These kind of problems that make you not love geometry problems so much. Sometimes you can run into a geometry problem that's just really, you got to do real out-of-the-box thinking. I just saw something. Well, now hold on. Let's see. These are similar triangles. I did figure it out. This side right here
is equal to
that side right there.
Mm-hmm.
Which means that we have B plus something. Let's call that Z. That little tiny side right there.
Z equals A plus B. Well, I mean...
Well, Z plus B equals that whole side. Wow. In other words, the height, if I'm looking for the area of the triangle, it's 1/2 the base times the height. So 1/2 the base. This base is B. Excuse me, B plus A. Right?
And then
In other words, this is right triangle, so that's equal to that. So this is B, so that's B plus A is the base of this triangle.
And so is the height.
Is the height exactly B plus A also?
Yes.
Yeah, because that's A and that's A. So it is B plus A. So we have the area equals 1/2. Well, we know B plus A is 6. 6 squared, 36, 18.
Yay.
Sometimes geometry is just magical when you see certain things that you didn't see before. And then it all falls into place. Ooh, that was 666 too. The sign of the devil.
D, 1 and 3 only.
Well, 1 and 3 for sure are true. And A does not have to be equal to B at all. So all I have to do is change the slope of that line, and clearly A would not be equal to B. And yet everything else would be true. In other words, sometimes I like to kind of solve these problems not mathematically but graphically. In other words, if I can see that that's their picture, but if I were to make it look like that, everything else would still be true. And yet it would change the relationship between A and B. So
Six.
how that problem got on there. Well, in fact, we're on 11. It's very rare for these came off of, I've got a book that has 12 SAT tests in them. And every question is rated either easy, medium, or hard. And so I went through the whole book, all 12 tests, and I found any hard question, and I photographed that page and put it in this folder. And what I found that almost all the hard questions are much higher than 11. I don't ever remember a hard question being this early in the numbering sequence before.
The guys that teach my ACT class, they were saying that usually the last 15 problems are the hardest.
Yes, I agree. I've always used 30 as a cutoff on ACT. In other words, if I'm working with somebody that's particularly good and just trying to really improve their score, I usually will skip the first 30, and I'll start on 30 and go 30 to 60.
Yeah.
Just to cover medium and difficult problems. And, you know, some of the practice books, though, don't seem to do that. Lately I've been discovering some of the ACT, like the McGraw-Hill ACT. It's not always like that.
Oh, that's weird.
Yeah.
I think that wouldn't be very helpful.
Yeah, it would be actually. So what about this one?
A has to be less than B.
You're no fun.
What?
I said you're no fun.
What? Why not?
You know all of these. What am I to
don't.
do?
I don't know all of them.
Most of them.
$165.
Boy.
Am I right?
Yeah. Yeah.
Yay.
No. Yeah. In other words, you know this is 60, that's 45, and that's 90. So that's what you did, right? You added those three and subtracted from 360?
Yep. B cannot be 5.
If B were 5, we would have this, right?
It's plus.
Just says integers.
Oh, never mind. I did this the wrong way. I'm sorry.
It's all right.
No, I didn't.
How are you doing it? Are you back solving?
Yeah.
So if we start with 5, and it's as good as number as any to start with, because we're not going to know plus or minus. In other words, we're not going to know up or down. So starting with an easy number is fine. Don't I get 2a plus 25 equals 15, which means 2a equals minus 10, which means a is minus 5, and that's allowable.
Yeah.
So that can be an answer for B.
Yeah.
So let's test the others. How about 3?
Oh, it can't be 3 because then A would be 0. But that's an integer too.
That's right.
If it was 2, it'd be A would be. Oh, it can't be 2.
You
Then
got
it's
it.
not an integer.
That's it. Ooh, I like these.
Oh God. Y squared would be less than 1.
Right?
1 minus y would be greater than 0. No, would be greater than 1. One plus y would be less than 1. 2y is going to be greater than 1.
2 times a negative number is still negative.
Yeah. And then 1 over y plus 2 is going to be little.
Well, it's going to be less than 1/2. No, hold on a second. Just a second. If y were minus 1, that could at most be less than or equal to 1.
Yeah.
So which is the
So
greatest?
1 minus y.
Looked like a Venn diagram problem. Number 16, but let's look at 15 first.
So 29 drive, but only 6 men take public transportation. So
Let's do 15. I'm sorry. Not 16, but 15.
Oh, 15, sorry.
Sorry.
Yesterday is 3.
Excuse me. It's allergy season, and I've been playing golf. Played golf 3 times this week. Yeah.
How was it?
Beautiful. Spring has hit.
It has.
Yeah. So what does set B consist of?
2, 4, 6, 8, 10.
So what's the union of that set with the union of the other set?
2, 3, 4, 5.
How many units, how many elements are in the union?
What do you, I don't understand that language.
Okay, this has 5 elements. This has 5 elements.
So 10.
10, yeah. The union is when you add them all together. If you had the, let's see, the other thing is this thing instead of the union. This thing means elements that are common to both sets. This means all elements that are in all sets. This is the union, and I'm not sure what that's called. That would be how many elements are common to both sets, I guess.
Okay.
Hold on. Is this a Venn diagram problem?
Yes.
Yeah, it is. This is a typical Venn diagram. Draw a rectangle with 2 circles in it that overlap.
6 women drive to work.
Okay. And there are 4 possibilities, right? There's women that drive to work, there's women that take public transportation, there's men that drive to work, and there's men that take public transportation. And this particular Venn diagram gives you 4 options. There's this area, that's 1. There's this area, that's 2. There's the combined area is 3. And there's the area outside is 4. So when we have a problem that has 4 possibilities, we should be able to set it up as a Venn diagram. Now let me think for a moment. Even though you may have the right, are you sure of that answer? I don't know the answer yet.
No, I'm not sure.
Let's go through it then. Let's see, what am I going to do here? Now that I think about it, I'm not sure this is a Venn diagram. It might just be a table problem.
Oh, 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 oh.
What?
It's 10. It's 10. It's 10. It's not 6. It's definitely 10.
Okay, how'd you get it?
Okay, so if 29 employees drive to work, and we know that only 6 men take public transportation, and we have all the men, so 19 of those 29 employees that drive to work must be men, so 10 must be women.
Okay. Sounds like you know what you're talking about. However, in general, let's look at this other solution here. This method, which I've found not that familiar with this method, but I'm pretty sure it applies to this problem because the Venn diagram didn't seem to fit this very well. When I laid out the Venn diagram, we have 4 possibilities. Well, the 4 possibilities we're going to look for are those, when you have something where you have 4 possibilities, there's the 4 possibilities, and let's make these totals. And this would be men, women, public transportation, and drive to work. So we know the total women are 25 and the total men are 25. 29 employees drive to work. So this is another total line here. So 29 is there. And 6 men take public transportation. So we know that's 6. So I've filled in enough spots on this thing that I can complete the table. And that's why this is a table problem and not a Venn diagram. Do you see now how I can algebraically solve it?
Uh-huh.
In other words, drive to work men has to be 19. That means women who drive to work has to be 10. We're done. But it also means women who take public transportation would have to be 15. The total that take public transportation would be 21. In other words, we had enough information that we could fill in every other square. I don't know how you did it, but that's fine. You got the right answer. You basically probably used you probably did this. You did that, you just didn't lay it out in a table. But notice, let's talk about this because this is a high degree of difficulty problem for sure. And the answer is either going to be a Venn diagram or a table. And the key part of the table is this part right here. There's 4 possible things. And we need another column for totals, and we need another column for totals horizontally. So whenever there's 4 possible options, I make a square with 3 columns and 3 rows, knowing that I need a row for total and I need a column for total. And then just start filling in everything you know. And when we did that, then it was simple algebra to figure out how many women drive to work.
And that last box is 50.
Yes, it is.
Sorry.
That's okay.
Kind of OCD about that.
It took me 2 years to learn this method. It took me a long time to learn, and I've learned it, just this moment. When you use a Venn diagram and when you use a table.
You use a Venn diagram with 3 possibilities and then a table and there's 4.
Yeah, but you can also use a Venn diagram with 4 possibilities. I've had problems where you definitely can use a Venn diagram with 4 possibilities because notice what we have. We have that part of the circle. We have that part of the circle too. We have the combined, which is 3, and we have everything outside the circle, which is 4. So the Venn diagram with a rectangle and 2 circles actually covers 4 possibilities, but I don't believe we could have used it on this problem, or at least I couldn't see how we could, whereas the table works beautifully on this, because we know everybody fits into those 4 categories right there. Oh, I didn't photograph the very right side of that. The slope of the line is minus 3/2. What is the area of that triangle?
So B is going to be 4, 0.
Okay.
So it'll be 12.
Good. Noon temperature reading in this city in degrees. This looks interesting. The median temperature for the whole week is 73 degrees.
So 67 plus 71 plus 72 plus 73 plus 76.
Not mean, median.
I don't know the difference between those.
Mean is average, median is middle. If I had this series of numbers, the mean is way bigger than 3, but the median is 3.
Oh, so it wouldn't matter what the next two numbers are.
Well, yes it is. The 73 has to be the median. So we've got a Saturday and a Sunday temperature, and 73 has to be the middle between all 7 numbers.
That makes no sense to me.
Okay. I'm going to list out the numbers, the temperatures in order. Now, for that to be the middle of 7 temperatures, in other words, we're going to have a Saturday and a Sunday temperature. If I looked at A and made Saturdays and Sundays, that is 73 the median of those 7 numbers? No.
Why not?
Because it's not the middle. First of all, you have to put all the numbers in order. So if I were to order these 7 numbers, I would have this.
Oh, okay, I understand.
And the mean would not be 73. It would be 72. So what 2 numbers can I put in that series to make 73 the middle one?
It has to be E.
Yes. The 3 things you need to know are mean, median, and mode.
What's mode?
Most common.
What?
Most common. If I put a 72 there, the mode is 72.
Okay.
Okay? The median is the middle. If you have an even number of numbers, then the median is halfway between the In other words, the median between these three numbers. Well, let me make this 77. Okay. If I wanted the median of those 6 numbers, it's 72.5.
Okay.
If I wanted the mean, I would add them all and divide by 6. And if I wanted the mode, there is no number more common than the other. So any of them are the mode. But if I did have a number that repeated, was in there twice, that would be the mode.
Okay.
Wow. We're to that part of the test where we're only getting like 2 questions per page. And I'm running out of pages fast.
I'm sorry.
Oh my gosh, we're done. After this question. It's all right, I'll find other stuff we can work on.
Of course they draw it in some weird contorted way.
Of course. That's their specialty. Actually, I kind of like that. Because if they draw it to scale, then you can solve the problem without doing the math. You can solve it by looking at it. So I kind of like that they draw it not to scale, because then you have to do the math.
I like when you can look at it.
I know. I'll let you think about it for a minute or two before I pipe in.
I think it's A.
No. What are the constraints on B plus D? Angle B plus angle D. Have to be greater than what and less than what?
They have to be... Oh, I see. So it's E.
Okay, I don't think E is right either. But
why?
B plus D has to be greater than 70, right? Because B could theoretically be 0. Just says it has to, that angle has to be less than 45. So B plus D has to be less than 115, 45 plus 70. It has to be greater than 70 because we got a 70-degree angle there. So even if x was 0, B plus D would have to be greater than 70. Well, if B plus D have to be between 70 and 115, then A plus C, or what they call W plus Y, has to be greater than what?
185? No, 115.
Well, 360 minus that.
So
in other words, all 4 angles have to add to 360. It's a quadrilateral. So 245, in other words, if x was 45 degrees, the biggest it could be, then that would make W and Y the smallest they could be. The smallest they're going to be able to be is 245.
Okay. So
but
D.
if B plus D is equal to 70, then W plus Y could be 290.
Gotcha.
All right. Well, that's pretty good, Emily. I threw the toughest stuff I have at you, and you scored at about, I would say, 90% on my high degree of difficulty problems. We don't need to worry about today, but let me just look at what other stuff I have. I know that in general we're not going to be doing that much more SAT. Let's see.
Well, for like the next month, we should probably do AP review.
I agree. I think we should too.
And then once I take the AP test, we can go back to SAT.
Well, you're awfully good at SAT. I can't believe you're not going to get a 700 or higher on it, if you want my honest opinion.
Well, I got.
If you get less than 700, I'm going to be disappointed.
Uh-oh.
I am. I've taken it, and I know your skills, and I've worked with so many students now, and if I was putting an over and under bet on it, it would be 700.
Uh-oh.
Well, that's what I think.
Okay.
I mean, I don't know what will happen on the day you take the test. Maybe you'll not be your brightest on that day, but all other things being equal, you should get 700 on this stuff.
Okay.
So let's stop for today's session, and do you want me to try to find more? Do you have SAT questions? You do. You have that book.
I've got a whole book of them.
But the problem is your book is beginning, medium, and hard all combined. So we could spend an hour on that. We're only going to spend 20 minutes of it on the stuff you need to spend on. You need to be doing only hard.
Well,
So
the easy ones I miss a lot too, just because I think they're too easy and I breeze right through them.
all right. Well, we can certainly have a session out of your book. You can maybe take pictures of it and send it to me or something. I've got a lot more questions, but and in fact, see, I have the subject math book also, level 1 and level 2, but I'm not sure that I'm not sure that's really going to be super beneficial for you.
I'll end up taking that next fall probably.
Well, the only difference between the subject math and the regular is it includes pre-calc and trig. It's not so much that much harder. It just includes some additional math disciplines that are not included on the regular SAT. But
Yeah.
So that's why I'm saying I'm not sure this is a good substitute for us. What we really need to find, if we're going to continue to work on SAT, is more difficult SAT questions. But if we're going to spend most of the next month on the Calc BC, the AP test, then we probably don't really need to worry about it. I won't spend a lot of time looking for more material. Because I go to the library often enough that I can always pick up a book and find additional problems.
Okay.
Or if a push comes to shove, we can use the problems out of your book. It's just you got to get them to me somehow. Or maybe when I'm over there Sunday, I can start taking pictures of some of them. Speaking of that, a snowstorm is supposed to hit Sunday. So if we got a lot of snow out or something, I'll be asking you to do that session online. Where are you at on chapter 10? Are you at 10.3 yet?
Yes, we are.
You at 10.4 yet?
No. We're
So
starting 10:30 today.
You're starting 10.4 to when?
Next week. We started 10:30 today.
Okay. So the furthest we'll get is 10.3 on Sunday.
Yes.
Okay. Good. And I'll bet you only have probably one more week.
Hopefully we will need to start reviewing.
10.4. I think it only goes to 10.5, doesn't it? Yeah, I think it's 10.
I thought it only went to 10.4.
No, I think there's a 10.5 also. I don't know. Let me look.
Oh no. Okay.
Open my book. I got a 10.4, which is modeling. Yeah, it's actually a 10.6, the calculus of polar curves in my book. So you still got half that chapter still remaining. So maybe another week or two. Okay. I will see you on Sunday.
Perfect. Thank you very much.
Have a good weekend. See you then.
You too.
Bye-bye, Emily.